You have your two vectors are at right angles to each other. This is like, it's really simple, but sometimes I forget to go through it because it is so simple that when you hit the example or you hit a question on your test, you don't know what to do, right? What I mean is if your two vectors that you're adding are at right angles to each other, what do? And the answer is you simply just draw the vectors because essentially you've got the x component, you've got the y component, you're looking for the resultant. So here's our example. Ferd skips along. Okay, write down the example, pause, and we'll move on to the solution. So in order to find the magnitude and angle of his displacement, magnitude being the size, the number value, you just draw a triangle. So you draw his path, right? So he starts by going 20 meters south. So here's where he starts. He goes his 20 meters south. Then don't pick up your pencil because then he goes a 50 meters east. And his overall displacement's from where he started to where he finishes, right? And the angle is depending on, we'll find the angle, the enclosed angle near where I started drawing. Okay, and whenever you're confused about what angle do you look for, because I know it is one that gets often confused, you always find the angle close to where you start, the start of your journey, the start of your drawing, not the finish. Okay, so we want to solve then for his displacement. Well, this is a right angle triangle, so it's just Pythagorean theorem. You find the magnitude of delta D is 54 meters. Find the angle using inverse tan, and you find that 68 degrees. So then his overall displacement then is 54 meters, 68 degrees east of south, right? Because here's south and he's 68 degrees away from it. And that's it. And I think that looks like a good answer, so I'm going to check mark it. Done.